Before we give some other examples, we would need another notion, that is the notion of a functor. Recall, whenever we have had a structure, there was a structure preserving map. Category itself comes with a structure. And what is it? The structure is, well, there are objects, there are morphisms, there is a codomain, domain of a morphism, there is the identity object, and there is the composition. So a functor we'll even write like this: from a category A to B is, remember, A is actually given by this 6 tuple, and B is given by a similar 6 tuple, and what I am saying, a functor f is a pair of functions is where f0 f1 are functions such that, firstly it takes objects to objects. Morphisms are mapped to morphisms, but I must have the domain and codomain of a morphism to be. So that means if then f1 of f should be from f0 of A to f0 of B. So what am I saying? So that means I am actually, with respect to this diagram, I am saying f0 partial 0 is partial 0 f1 and f0 partial 1 is partial 1 f1. That means the top square and the bottom squares commute. Secondly, for any A object, the identity morphism on A must be the identity morphism on F naught A. So which is, I am saying that is F, that is, I am saying EF1 is equal to EF0 is F1E. Okay. So in other words, this part of the diagram reasonably commutes. The top squares commute, the bottom squares commute, and the middle squares also commute. Okay? And finally, there is another structure which is the composition. If in A, then F1, this is F1G composed F1F. Okay, there's something to be checked whether F1G, but the first condition immediately says that if GF is composable, then F1G and F1F are composable. Okay, so just as a remark, under A, GF is in A2 implies F1G and F1F is in B2, so that there is this function okay, there is this function, and hence C says something. So you automatically have this function, and then C says that with this function the left square commutes. So that means MF2 is F1. Okay, so it's a functor is a pair of functions. F0 is often said to be the object part of F, and F1 is said to be the morphism part of F. Okay. Now, henceforth, we will just drop the subscripts, for it's an abuse of symbol. F0 and F1 replaced by F. So what does it say? It takes objects to objects, morphisms to morphisms, such that if so A becomes F if then f of f is from f of A to f of B, where here I mean obviously the object part of f coming into the picture, here the morphism part of f coming. So this is actually f1, this is actually f0. F of 1A is 1 of fa, and C becomes if then okay. So in the simpler language. So this is a function. This is a functor. Okay. Let's now look into some more examples of categories and functors themselves. Well, carrying on, I think it should be